Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. Welcome to Wednesday Night Math Night. I am so excited to be here with you. Like Dr. A said, my name is Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And we just love helping you feel more confident in your subject that you are taking for your upcoming test. I specifically love helping you with math. So, we are here every single Wednesday. We solve problems together. We process them together. We ask questions of each other, and then we finish up. So we're here for about an hour every Wednesday. We do have new summer hours. So normally we are here from 6 to 7 Eastern Standard Time. But right now for the summer, we will be here from 5:30 to 6:30. And that is just due to some scheduling changes in my family. And so we will be here from 5:30 to 6:30 during the summer. Welcome to the summer hours. I'm going to have to share a picture with y'all next week. I was going back and forth with Dr. A and Matt, one of our tech guys. And he was like, what kind of photo should we use for summer hours? So you're going to have to check out the picture on Facebook and like it for the stream today with my snorkel on, and then I'll show you the photo that we were thinking about using. You have to dig far into my Facebook to find it, but I did post it, so I guess it's free game. So I'll show that photo to you next week. It's definitely a funny summer photo. So that's your bait to come back next week, is to see the funny photo. I always like to ask you where you're from, what test you're prepping for, and that helps me get to know who's in the room, and where you're from, what test are you prepping for, and I always like to do a get to know you question. So do you like snorkeling? Normally I do this or that. Today's question is just going to be, do you like snorkeling? The first time I ever went snorkeling, absolutely hated it. And now I love it. I love being able to see the fish. I don't like it if the fish or the animals come too close to me, but I do love snorkeling. So do you like snorkeling? Yes or no? And are you excited for the summer? I mean, it's not really summer yet for us. We still have a few weeks of school and work and all of that, but are you excited for the summer? All right. So where are you from? What test are you prepping for? And do you like snorkeling? Without further ado, let's go ahead and get started. If you have any questions at all while I am solving these problems, please don't hesitate to ask. Ask questions in the comment box. That's why we're here, to help you. So ask questions in the question box. Let me know what you want to see me go over in the upcoming weeks. So I'm going to add a next week section, which I always have. So let me know what you want to see me go over in the upcoming weeks. And other than that, we will go ahead and get started. I always like to add the next week just because this is for you. This is not for me. Well, I mean, I love it, but this is for you. So I want to make sure that we are able to cover the topics, cover the questions, cover the things that you want to see. So if there are topics that you're like struggling with or questions that you're struggling with, let me know, because that's how we learn together. In fact, there's a question that's going to come up tonight that somebody posted on our Facebook page, and I was like, I will absolutely go over that tonight. So they posted on the Facebook page, and I included it in tonight's presentation. Hey, Jen, it's good to see you. You're from Tampa, GK Math, and you love snorkeling. That's awesome. Hey, Susanna, you're from North Carolina. I grew up in North Carolina. You've never been, and you're excited for summer. I love that. You should totally go snorkeling. I guess it's like something I'm used to because we live in Florida. But yeah, you should totally go snorkeling. Jen, you're like a hop, skip, and jump from me. I could throw a rock at you, and hit your house. We are in Orlando-ish. But we were in Tampa the other weekend. We went to the Florida Aquarium down there. So you could have met us at the Florida Aquarium. All right, let's go ahead and solve the first problem together. Problem 1A. Find the slope of the line tangent to the vertex of y equals 2x squared plus 8x minus 1. Alrighty, so this problem is definitely for my high school people. Like if you are taking 6 through 12, 7 through 12 math, this problem is for you. Now, we are going to go over problems that span K to 12. So if you've not been to math night with me before, I always like to make sure that I cover a variety of things, but I also try to take every problem and relate something back for everybody. So if you pay attention closely, you'll notice, like, yes, elementary people, GK people, you don't need to know how to find the slope of the line tangent to anything. But let's chat about what this problem is, and you'll see where I'm going with this. So find the slope of the line tangent to the vertex of y equals 2x squared plus 8x plus 1. So if I were to draw a coordinate plane and I were to graph this, it really doesn't matter where I graph it. I could graph it here. Actually, I'm going to use a different color. I could graph it here. I could graph it here. I could graph it here. It really doesn't matter because all of them have a vertex that is at the bottom, right? Like this. Now, I know that my parabolas are upward facing. Why? Because this value right here is a positive value, which means it's an upward facing parabola. Now, when I think about the line tangent to the vertex is going to be this line right here. Tangent means that the line touches that shape at exactly 1 point. So if I were to look at the line tangent to this graph right here, that's an eraser, right here, then that line would go like this. And really, it looks like it's riding on that parabola, but it's only touching at exactly that one point, and it would have a slope, right? But what do you notice about the slopes of all of the lines that are tangent to all of the vertexes? They all have a slope of 0. This is a question that they wanted you to like really, really stress over. And it really, really wasn't a stressful question, was it? Now, how do we find slope of the line tangent to a function? Slope of the line tangent to a function. How do we find that? Well, we find the derivative at that point. So we're going to take the derivative of this function, and then we plug in that value into that function to figure out what the slope is. But like I said, vertex, the slope of the vertex, the slope of the line tangent to the vertex of any parabola is always going to be 0. So that's like the trick question in this one. All right, let's go ahead and look at problem number 2. Now, this one was specifically requested by somebody on our Facebook page. Let's take a look. Rick pulled a card at random from a normal deck, noted it, replaced it, shuffled it, and drew again. His draws were as follows: a 10, a jack, a 10, a king, a 1, 2, 6, 10, 11, and 4. What is the probability that he will draw a 10 on the next draw? So this is another interesting question because we're talking about probability. What is the probability? Before we get caught up in all of this, I want us to consider what they're asking us for. Probability is defined as the number of desired outcomes over the total possible outcomes. That is probability. So what is the number of desired outcomes in my deck? Well, let's take a look at what this deck really looks like. So Rick pulled a card at random from a normal deck. A normal deck of cards has 52 total cards. So I know that my total possible could be 52, but it also could be less than that. It depends on the way the question is worded. So he's pulling a card out. He writes a note down. He replaces that card back in the deck. So when he's doing this, it's not like he has a pile of cards next to him. He literally has the full deck. So he is still holding on to 52 cards in his hand. He shuffles and he draws again. He notes it. He puts it back in the deck. So the probability that he is going to draw a 10 on the next draw is the same probability that he's going to draw a 10 on the first draw, the third draw, the fifth draw, the 12th draw, or the 422nd draw, because he's replacing the card back in the deck. So it's the same probability of drawing a 10 out no matter what. My total is 52 cards. How many 10s are in my deck? 4. So my probability is 4 out of 52. So when we look at that, that is not an answer choice. That is not an answer choice. So what do we have to do? We have to simplify that fraction. So I'm going to divide everything by 4. So my answer is B. Now, what if this question changed just a little bit? What if I did this? I'm going to change the question just a little bit and tweak it just a little bit. So what if instead of, and I'm going to keep some of these notes, instead of replacing it, what if, now I don't know what just happened. The connection just completely went away. So I'm trying to relink my iPad, but let's go back to that question. What if instead of replacing it, he doesn't replace it and he pulls that card out of the deck? What would we be dealing with? Well, in that case, the entire problem changes. In that case, the entire problem changes because now I don't have 52 cards in my deck. Now I have however many cards, 52 minus the number of cards I've pulled out in my draws, right? And so that is where we have to really be careful. So I am going to work on getting my iPad connected, and then we'll talk about how that answer would change as a result of that one tiny word changing in the problem. So I'm connecting. All right, it looks like we are moving and grooving, moving and grooving. Come on. All right. It is not wanting to connect, and I don't know why. All right, we're going to go like this for a little bit and let it like kind of reset. So we're going to go old school. So instead of replacing, I just tried to use my makeup brush to do that. Not replacing. So if we are not replacing that card, then instead of 52 cards in my deck, I now have 52, 51, 50, 49, 48, 47, 46, 45, 44, 43, 42 cards in my deck. Because all of those cards, the 10, the jack, the 10, the king, all of those cards are sitting in a separate pile on my desk. So now instead of 52 cards, I have 42 cards. And now it's not 4 10s. How many 10s do I have left sitting in my deck? How many 10s do I have left sitting in my deck? We only have one left. I literally only have one left because there are 3 out of the 4 10s sitting in this pile. So instead of 4 out of 52, which was 1 out of 13 on the other problem, now our probability is just 1 out of 42. So you see how one tiny word in a probability problem completely changes the entire scope of the problem, right? All right, let's go ahead and move on to the next problem. And while we're moving on to the next problem, we're going to attempt to reconnect to our the computer because it is really hard to solve math problems and collaborate when the computer is not connected. So while we're waiting, let me know in the comment box if you want to see me solve anything specific in the upcoming weeks. Like, is there a specific topic that you're struggling with? Is there a specific question that you're struggling with? Let me know, because I will absolutely be sure to include that in the upcoming weeks. Fingers crossed, toes crossed, hairs crossed that this works and that it connects. Actually, otherwise, we can do what we did last time and do this. I did this one time and it worked really well. Let's see. There we go. Let's do that. I mean, it's not ideal and I can't really write, but I can at least write on my iPad and then share it. So let's do this problem. A single chain link is created from a piece of cylindrical metal that had a height of 22 millimeters and a diameter of 5 millimeters. If the chain link is being wrapped in plastic, what is the exact amount of plastic that is needed? What is the exact amount of plastic that is needed? All right, so this is interesting. This is a fun one. So I'm going to kind of make notes on my iPad and then I will share it with you like every once in a while, but just listen to me talking as we're chatting about this. So we are talking about only one piece of chain link, not both, right? So we're talking about, like, this picture has two chain links, but we're talking about just one of these chain links. And you can see my mouse is kind of like circling that. So one single chain link is being created from a piece of cylinder metal. So we took this piece of cylinder metal and then we bent it to create the chain link. It had a height of 22 millimeters and a diameter of 5 millimeters. The chain is being wrapped, the link is being wrapped in plastic. How much plastic is needed? So really, a lot of us are going to immediately think, oh, I know the answer to that. We're doing the surface area. We are doing the surface area of a cylinder. Totally. We're doing the surface area of a cylinder. All right, let's go ahead and do that. So I'm going to draw my cylinder that the metal came from, right? Here's my cylinder that the metal came from. And I'm going to label it 22 millimeters high, diameter of 5 millimeters. So when I think about the surface area of something, I'm thinking about putting paper, putting plastic, putting paint on the outside of that piece or of that shape. When I think about a cylinder, I have a circle on the top, a circle on the bottom, and I have a rectangle. And actually, we can use this piece of paper to create a cylinder, right? So here is a cylinder. I have a circle on the bottom, I have a circle on the top, and I have a height, which is 22. What happens when I unravel that? What shape does that create? A rectangle. A cylinder is a rectangle with two circles. And the height of the cylinder is going to be the length or the width of that rectangle. What is this dimension right here of my rectangle? How do I find my length or my width of my rectangle? What is that of my circle? That is the circumference of my circle. So yes, elementary people, you don't necessarily need to do all of these calculations, but you need to understand properties of cylinders. My cylinder, when I unravel it, is a rectangle. So the circumference of my circle is going to be the length and width of my rectangle. So I need to find the circumference of the circle to figure out the length or width of my rectangle. I'm going to multiply that times the height, but then I also need to do the area of my circles, don't I? Or do I? Dun, dun, dun. I don't. And this is actually a mistake that I made when I was solving a problem like this. So we have our cylinder piece of metal. And then I take this and I bend it and I create a chain link with that. Do I need to cover the ends of my cylinder in plastic if I'm joining them together? I don't. That's what my brain did when I was solving this problem. I do not need to cover that part of my cylinder. So all I need is the rectangle part of my cylinder to cover it in plastic. Because when I bend this up and I join those two ends together, I'm not covering the two ends in plastic because they're welded, melted, whatever you want to call it, together. So I literally just need to find the circumference of my circle times the height. Let's go ahead and do that. The circumference of my circle times the height. So circumference equals, what is our circumference formula? What is our circumference formula? And I actually just came up with another brilliant idea so that you can see me thinking and processing. Watch this. It's not going to be clean because I'm using my computer, but it'll be something. So circumference equals 2 pi r. That's our circumference formula. So when I'm solving for circumference, I'm going to do 2 pi r. What is the radius of my circle? The radius of my circle is 2.5 because the diameter of my circle is 5. They told us that the diameter of the circle is 5 and that the height of the cylinder is 22. So if I put in, do I have a cylinder? I do. If I put my cylinder in here, the height is 22, the diameter is 5, but remember, we don't need the surface area of the top and surface area of the bottom, so I literally just have to find 2 pi r, so 2 times pi times r. There's the length of my rectangle times the width of my rectangle is 22. Or if you want to think of the length as 22 and the width as the circumference, that's fine. Now all I have to do is use my handy dandy calculator. My handy dandy calculator says 2 times 2.5 times 3.14. That's 15.7 times 22, 345.4. That's your answer, 345.4, when I just multiply all of that together. Now, if you found the surface area of the top and the bottom and added it all together, you would have gotten one of those answer choices. Absolutely. So we have to make sure we're only finding the pieces that are necessary for the problem. And this problem was kind of tricky in that sense. All right, let's go ahead and move on to the next problem. The sum of the digits of a certain two-digit number is 15. Reversing the digits gives a number which is 9 less than the original number. What is the original number? What is the original number? So this is one of those problems where I would absolutely, if I didn't know how to do it, use my answer choices. So the sum of the digits, sum, addition to an answer problem, digits, the singular numbers in a multi-digit number. So the digits of 69 are a 6 and a 9. The digits of 78 are 7 and 8. The digits of 87 are 8 and 7. So the sum, if I add my digits together, it should equal 15. 6 plus 9, 15. 7 plus 8, 15. 8 plus 7, 15. 9 plus 6, 15. Well, that did not help me eliminate any answer choices. However, let's look at the next section. The next section says, reversing the digits, flip-flopping the digits gives a number which is 9 less than the original number. So if I flip-flop the digits, now it's interesting because when we look at these answer choices, I have 69 and 96 reversed digits, and I have 78 and 87 reversed digits. Which of these is 9 less, 9 more than another? 69 and 96 or 78 and 87? 78 and 87. So now I can absolutely get rid of A and D because those are not 9 away from each other, right? 78 and 87 are 9 away from each other. So if I reverse the digits, it gives me a number that is 9 less than the original number. So the original number is going to be greater than the new number because the new number is less than the original number. So in this case, the original number is going to be 87. Let's check it. 8 plus 7 is 15. If I reverse the digits and I go from 87 to 78, is 78 9 less than the original number? 78, 79, 80, 81, 82, 83, 84, 85, 86, 87. It is. So 87 is going to be the correct answer. Questions so far? Comments, concerns, other than the fact that the iPad is not connecting? All right, let's go ahead and move on to problem number 5. What is the value of sine of 7 pi over 3? So this is going to be a little bit difficult to draw out because normally I would draw out my unit circle, but drawing it out with a trackpad mouse is not going to be possible. So what I am going to do is I'm going to draw just a little bit of it. So if I am taking a high school test, then I need to know my unit circle. So here's my unit circle, and I know that I have cosine and I have sine, and cosine of x is going to be my x value of my coordinate point on my unit circle, and sine is going to be the y value. So when I think about my pi over 3 angles, I have 0, 1 pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, 5 pi over 6, 6 pi over 6. And when I think of 6 pi over 6, I can also think of it as 3 pi over 3. So right now, I only am up to 3 pi over 3. So where am I going to get when I get to 7 pi over 3? If I go all the way around again, what is that going to give me? That's going to be too much. You're absolutely right. So if a half a circle is 1 pi, then another half of a circle is going to be 2 pi. Exactly. And 2 pi equals 6 pi over 3. So then 7 pi over 3 is going to be this angle right here in the first quadrant, because I've gone around my circle one whole time and I've come back to the first pi over 3. So sine of 7 pi over 3 is going to be whatever angle that is. Well, my x comma y, when I think about this conceptually, this right here, we know that this point right here is 1 comma 0. And if you don't know that and you're taking a high school test, you got to know that, because I'm going over 1 up 0. And this is 0 comma 1. Well, when I look at this value right here, this is about a half. And when I look at this value right here, I am so close to y equals 1. So my x value is going to be 1/2, and my y value is going to be square root of 3 over 2. And I never memorize this. I always draw it really quickly and look to see where I'm at. Because as soon as I do that, I can very quickly see if I'm in the half or if I'm in the square root of 3 over 2. So because the y value is square root of 3 over 2, sine of 7 pi over 3 is square root of 3 over 2. Cosine and sine are not going to be square root of 2 over 2 unless it's a pi over 4 angle. So this right here are your pi over 4 angles, not your pi over 3 or your pi over 6 angles. All right. Questions about that? I kind of went through that super quickly because it's not really for my GK or elementary people, and because I'm using a trackpad mouse, and because you just kind of have to know the unit circle to be able to reason through that. So let's go ahead and move on to problem number 6. Which of the following correctly gives the area of the unshaded portion of the figure below? Which of the following correctly gives the area of the unshaded portion of the figure below? This is a really, really interesting problem because number one, they usually ask for the shaded portion, but we're looking for this unshaded portion. And number two, it's composite area on steroids. So we're having to find the area of this weird shape right here. But then we also have a shaded circle in the middle. So I'm kind of thinking, if this was a real world problem, that I have like some rectangular garden and I want to know how much grass I need for my garden, but I'm not going to put grass in the pond. And so I have to take the pond out of that equation, right? So I need to find the area of my irregular shape. And then I need to find the area of this circle, and then I need to subtract it out. So there's my steps. There's my process that I'm going to use for this problem. So area of the weird oblong shape. We can do this two ways. I can do area of the big rectangle, which would be 21 times 14, minus the area of this section, and then subtract the circle. Or I can cut my shape and I can do area of the green rectangle, area of the pink rectangle, and then subtract the circle. Or I could cut it one other way. I could do area of the green rectangle. I could do area of the pink rectangle and then subtract the circle. So there's a few different ways that we can do this. For some reason, I don't know why, I always like to cut the shape like this. I guess it's just habit. So let's go ahead and find the area of the pink rectangle. So I'm going to find the area of this rectangle. What is the length and what is the width of the pink rectangle? Length is 21. Width is 5. 21 times 5. I'm going to use my handy dandy calculator. $105. 21 times 5 is 105. So the area of the pink rectangle is 105. Now keep in mind that includes the pond, right? I just made up that it's a pond, but it includes the pond. Now let's find the area of the green rectangle. This one is a little bit more tricky. Some people are going to do 14 times 5. Some people are going to do 14 times 11. Some people are going to do 21 times 14. None of those are correct. I have to look at this rectangle and say, do I have a length for just this section? I don't. But what I do have is I have a length for this section. That is 5. And if the whole thing is 14, I can do 14 minus 5 to give me that green section, right? So 14 minus 5 is 8. No, 9. 14 minus 5 is 9. And then how do I find this section right here? How do I find that section right there? Keep in mind what we did for the 14 and the 5 and think about what you're going to do there. Well, I have to do 21 minus 11. You're absolutely right. Because this whole thing is 21, and I have to subtract out this section right here, which is 11, and 21 minus 11 is 10. So 10 plus 11 is 21, and so this section is not 20, it's 10. 9 times 10 is 90. So to find the area of the oblong weird shape, I'm going to do 105 plus 90 equals 195. Then I have to subtract out the circle. Then I have to subtract out the circle. So how do I find the area of this circle? Area of the circle, pi r squared. Now, elementary people, you should absolutely find GK people, everybody in this room should absolutely be able to find the area of that oblong, not standard shape. As soon as I throw a circle in there, that's where it takes it to the next level. So step 1 was finding the area of the non-standard shape. Step 2 is finding the area of that circle, and not everybody has to find the area of a circle. So keep that in mind, that not everybody has to find the area of a circle. So if you don't have to do that, this section's not necessarily for you. Now, how do I find the radius of this circle? Well, this 5 is there for a reason. The diameter of the circle is 5. So the radius is going to be half of that. Area equals pi times 2.5 squared. So area equals 2.5 times 2.5 times 3.14. So I'm going to do 2.5 times 2.5 times 3.14, which equals 19.625. 19.625. So I'm going to do 195 minus 19.625. 195 minus 19.625. 175.375, which is A. Questions about that? All right. We have, hey, Monique, it is good to see you. I love seeing familiar faces. In case you missed it, Monique, we are on summer hours. So summer hours, we're going to be doing 5:30 to 6:30, which I know is early for some of my not East Coast friends. So I apologize about that. I just saw a bunch of people come in, which means people didn't catch that we were doing summer hours today, and that's okay. We are going to be running 5:30 to 6:30 for the next probably better part of the summer, just because of some scheduling changes in my family. And then when we get back to the school year in August, we'll go back to our normal school day hours. We have time for one more, and then we are going to move right along and say adios. In the circle shown below, the length of AE is 8 units, and the length of ED is x plus 3 units. The length of EC is 5 units, and the length of BE is 5x minus 2 units. What is the length of BC? So in a circle has all sorts of rules and regulations. In a circle, if I have two chords, which are line segments that touch the ends of the circle that do not go through the center, if I multiply the first part of the chord times, oh goodness, I have to find my rules. If I multiply the first part of the circle times the second part of the circle, or the first part of the chord times the second part of the chord, it equals the first part of the other chord times the second part of the other chord. So watch what I mean. 8 times x plus 3 is going to equal 5 times 5x minus 2. That looks like 8x plus 24, distributive property for everybody in the room, even if you don't need to know these rules, equals 25x minus 10. From there, y'all, we literally just solve. So I am going to subtract 25x from both sides, and that gives me 17x. I'm going to subtract 24 from both sides, and that gives me negative 34. And I'm so sorry, that's going to give me negative 17x, because 8 minus 25 is going to be a negative. Divide both sides by negative 17, and x is going to equal 2. Now, if you've been here with me for a while, you know I would normally record all of these steps, right? But that's kind of hard to do when my mouse isn't working and my iPad's not working. So we're shorthanding it. Now, that is not the answer. They wanted to know the entire length of BC. So I'm going to plug x into 5x minus 2. So 5 times 2 minus 2. 10 minus 2 is 8. And then I'm going to add that to this segment right here, which is 5. And 8 plus 5 is 13. All righty. Y'all, we made it through all of our problems, and we did it well. I'm going to turn it back over to Dr. A, and what I want you to do is leave me a note in the comments about what you want to see me go over next week. I look forward to seeing you at 5:30 next week for our special summer hour edition of Wednesday Night Math Night. Have a wonderful week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.